Hello everybody, and welcome to my basic C# tutorial. I have created this entire code, and it is here that I will be demonstrating the use of various aspects as they are utilized within the C# language, including variables, expressions, conditionals, loops, functions, classes, and structures. Before I get into this, I would just like to point out that C#, while I am using Visual Studio Code, while I am using Visual Studio Code, C# is not a very friendly language when it comes to Visual Studio Code. A lot of other sources that I've looked at while constructing this code have recommended I instead use Visual Studio Community or Visual Studio 2019, but I guess you could say I love Visual Studio Code too much and I have instead found a way. Now, there are multiple methods for getting C# to work in code, but the one I did was by downloading another program called scriptcs, and that program would basically allow my terminal to execute the .cs files that I can create here um, as like executable codes. So as a result, I'm going to do so right now, and in the terminal, I can type scriptcs and then the name of my file, which is module04.cs. All right, looks like it's working. So the code hasn't finished executing yet. There's a piece of user input right here, but we'll get to that later. But for now, let's talk about what we've gotten so far. So to start off, I've typed out using system right here as my first piece of executable code, and that is because usually in C#, whenever you create certain command lines that involve the console or the terminal, you would type out system.component, which in many cases would be console, and then command, which if you're doing a print statement, for instance, it would be system.console.writeLine, as I have right down here. But as you can see, I don't have system dot beforehand. And that's because by typing in using system at the top, you can avoid this tedious task of putting system at the beginning of everything, because that will allow scriptcs to be smart enough to recognize when you're trying to do something like this, and then it will just put system at the beginning of those lines for you. It's also worth mentioning here that in most C# codes, you would usually also type in something like namespace and then just a name. It doesn't necessarily have to be your file name, I don't think. And then the entire rest of your code would just be underneath this namespace within square brackets. However, scriptcs makes it so that you don't have to do that. It will just use the actual name of your file as the namespace. So something I haven't had to do with my setup, but still something worth pointing out if you are using C# without scriptcs. So now let's start getting into the nitty-gritty of this code. For starters, I'm going to be talking about variables and expressing various different kinds of variables within the C# language. Just like every other language, you have strings, booleans, ints, floats, doubles, and chars. The char variable is something within C#, but it's very difficult to declare a variable as a char. I don't know if it's because of the way C# is written or if it's scriptcs, but that's because anytime you create a variable with alphabetical characters, it will do its best to default to string. Right here, I've just created a variable called word, and then I saved bruh underneath word. So now I can output it by typing in string variable plus word. And there it is. It has printed out exactly what I wanted it to. This quoted statement right here, and then just the value of my variable, which ended up being bruh. Usually in most other languages, you would put a quote statement and then a comma and then the variable name. Like you would have the comma separate those two, but in C#, you instead use this little plus symbol. So now we're going to move on to floats and doubles. Now, you're mostly going to be using int variables, and we're going to get to those down here since those are whole numbers. but I want to take the moment to talk about float and double variables here. Like in C++, anytime you declare a variable, it's going to require a certain amount of space to be able to save that variable. Float variables will take up 4 bytes of memory, whereas doubles will take up 8. And so because of this, float variables can only save decimal numbers up to so many digits long. As is the case here, I have typed out as many digits of pi as you see right here, but then it outputs down here as 1 or 2 numbers less. I would also like to point out right now that just like how alphabetical data will usually want to be defaulted to string variables instead of char variables, similarly, C# will want to default decimal numeric values like this as doubles rather than floats. I assume probably because anything you can save as a float you can also save as a double, but not everything you can save as a double can be saved as a float. Hopefully that made sense. And so because of this, I've had to sort of take a few extra steps when declaring something as a float, specifically by the use of this capital F right here at the end of my float value. I assume you have to do something similar for char, but I haven't been able to figure that out. And like I said, yeah, it's just a really difficult thing to do. Feel free to look that up, find someone who's more experienced in C# than me if you want. Now, one other interesting thing I found when declaring these float variables is that the rules that C# seems to follow when it comes to rounding are actually the same as what's taught to humans. I know for a fact in Python, at least, if you're trying to if, for instance, you're trying to convert a decimal value to an integer value, it will always round down. With C#, however, it seems to instead want to round up if the final value is 5 or more, and down if it's less than 5. So right here, I have this many digits of pi, 3.1415926, but down here it outputs as 3.141593, with the rounding up of this 2 to a 3. Because this is how many digits can be saved under a float variable, whereas down here with a double float, you can see it can save way more. Once again, I have output more digits of pi than a double float variable can hold within itself, and so once again, it just rounds. But instead, it rounds down because 3 is less than 5. So it just rounds down to that next value just staying at 9. Interesting. So now I'll be talking about integers, and notice how right here I was able to declare 4 different variables under one line, a, b, c, and sum, all of them integers with just one line. I can't recall a time I was ever able to pull off something like this in a previous programming language, and yet here I am. So for a, b, and c, I have assigned 6, 7, and 8 to be their values, and then sum, I've simply just said add up a, b, and c. So down here, when I'm outputting these things, I have the starting sum, which outputs in the terminal as 21. And then down here, I discovered yet another really interesting thing, but if you're trying to print something and every item within that print statement isn't an integer or a float or anything that is for sure a numeric value, then C# will treat it as if it really is just one thing being placed next to another. So even though I tried to put plus sum plus 9 here, it actually outputted as 219. Because like I said, the starting sum was 21, and then simply adding 9 to the end of that just turns it into 219. Very interesting. Now I was able to bypass this by creating another one down here, which was the same thing, except now sum and 9 were given their own set of parentheses. So now within this set of parentheses, the code is able to recognize, oh, both of these are integers, and we're trying to add up integers rather than just add a character to the end of a sequence, like this print statement apparently told it to do. So now I was able to get the correct sum of 30, 21 plus 9. Very interesting thing I accidentally figured out. I imagine this is going to have a lot of potential applications in the future. So Now we're going to move on to conditionals and loops. Just like with other languages, conditionals refer to just any time a code needs a certain condition to be met in order to be executed, like if-then statements or do or while loops. Down here I have, so to demonstrate this, I have created one variable called input and then another variable called conditional, the Boolean variable. Now, since input doesn't have any value assigned to it yet, that's what's going to allow this while loop to execute, since input currently does not equal lowercase y or lowercase n. So the first thing this while loop does is write out type y for true or n for false. Now, notice how previously I've been using console.writeLine for all my print statements, but in C#, if you take out the line and just put in console.write, you'll be able to write something, but then still allow more things to be put next to it on that same line. Console.writeLine will always start a new line and then output its things, but console.write will, just leave some space afterwards within the same line, where I've put console.readLine, which is what you will want to type in if you want input from the user. So here it is saying type y for true or n for false. Now I'm going to be a little bit rebellious and type in something else. So let's go with B. Okay, error, please type y or n only. So now because y still doesn't equal, because input, that's the name of the variable, because input doesn't equal y or n still, this while loop has in fact looped, and it's going to keep on looping forever and ever and ever unless I decide to type in y or n. So for now, let's just see what happens when I type y. Okay, it's run the entire rest of the code because I don't have any more user inputs here, but now that input does equal y, it doesn't meet the conditions of the while loop anymore, and it's able to break out and run the rest of the code. Starting right here, since we set earlier that the Boolean conditional from earlier would equal true if input equals y, I was able to output this statement right here, Boolean condition met. If I had hit no, it would have said Boolean condition not met, but I could still break free from the while loop anyways. And then if you're clever enough to somehow make it to this point without input equaling y or n, and while bypassing or breaking through the while loop, then congratulations, you are officially cool, I guess. And you'll just output regular error. So now we're going to move on to classes and functions. Just like other languages, functions refer to any block of code where you create it with the express purpose that it accomplishes only like one specific thing. And with those functions, you could then call them over and over again, but with different parameters passed through, so that you won't have to write out this function or the contents of this function over and over and over again. So right here, I have a function called average that I have declared as float because that's the type of output I wanted to have at the end with this return statement. With this function, I have basically created it for the purpose of outputting the average of two numbers, which will be passed in as num1 and num2. Notice how I've had to declare both num1 and num2 as integer variables within the parentheses of the function. So I have called upon this function 3 different times in 3 different print statements right here. Average of 5 and 7, 6. Yep, average of 50 and 100, 75, yes. And then just to make sure that I could truly output averages, since it's not likely that you're always going to get whole numbers as your average, and we definitely want to be as precise as possible. So I typed in 3 and 4 as the parameters here, and I was able to get 3.5 back. Because like I said before, I declared this function to output float variables, and when creating the formula for averages, I made sure to put that capital F after where it says divide 2. Therefore, the conversion to a float variable was completed. So now we move on to classes, and once again, just like with other languages, classes are a means of declaring lots of different objects that other parts of the code can pull from. Now, with C Sharp, whenever you pull things from classes, you'll want to always put those statements before the class declaration. I don't know if it's like C Sharp or if it's something to do with scriptcs, but basically, whenever you declare a class, it will not allow anything after that class to just be a regular part of the namespace, unless it's like another class or its own structure. And so, because of that, you're going to want to put all your classes near the end of your code, as I have done right here with the class I am about to demonstrate and call. So right here, I have within my class an object called declassified, which I have saved this block of text right here as. This is actually my Steam gamer tag for those interested. And I have declared this as a public object. Basically, anytime a field within a class is given this public or private declaration, it becomes a property. And this declaration is essentially supposed to declare the accessibility of this particular object when outside of this class. So, because declassified is a public variable, I am able to call it up, where is it? Up here, with this statement right here, info.declassified. And as you can see, it is in fact outputted down here in the terminal. I have this statement right here, which is essentially what you're going to want to do every time you do intend to call something from a class. You put in the class name and then just any shorter name that you want to refer to from that class, and then equals new, and then class name, and then class name along with these opening and closing parentheses right here. So now I can call that class with the word info, as I've done down here, and then after info I can put a period, and then the name of the object I want to call from that class. So like this, info.declassified. So the next object I've created within this class is a private object called classified. Now, because this is private, this means that you can't simply just call classified directly. I tried to do that while building this, and it actually caused the entire code to error out. So, what you're going to want to do instead, or at least what I've done, is create yet another function within this class that will allow you to obtain the information from this private variable, or this private object, I should say. So, I have right here a function called getInfo, and then I have right here return classified, return the values of this, and then set it to be the value that I want. So now I can just get the value of it out while dissociating it from the variable it was originally bound to. So with the variable getInfo, up here I've been able to call it with this line right here, info.getInfo, and here it is, my actual first and last name, which is also the first and last name of my current YouTube channel. So not very private right now, I suppose, but oh well. So now finally we move on to structures. And very similar to classes, structures are also a means of holding objects. But unlike classes, you can pull objects from structures as many times as you want, and then for each one you can add your own parameters and your own values outside of the structure. So with here, the structure I have called computers, I've put many different public variables: model, developer, color, and operating system. It's also worth pointing out that you can put any variables within structures that you want, whether it be bool or int or double or float or anything like that. Just remember what it is the variable is saved as if you want to put information in it. But for all of these, I have just put string. So up here, I basically called upon the computers structure 2 different times and created 2 new objects called PC1 and PC2, from which I can then assign values to each of these variables. So down here, I have each assigned variable under PC1, and then I can output all of them right here with this print statement, which then comes out down here. I have created a black HP developed by Microsoft that runs on Windows. That's the first computer I have built using this structure. And then down here, I was able to use the second one I made, PC2, to create a second computer, which according to my output statement is a white MacBook developed by Apple and running on iOS. So that is structures. I don't believe there's anything else down here aside from, oh, yep, there's my class that I used earlier. Because like I said, you're going to want to put all your classes just bundled up at the bottom of your code. And I believe that is everything. So thank you very much for watching, and I hope you all have a good day.